Okay, this is notes over properties of logarithms. As we're going through these notes, you should notice that a lot of these properties look familiar to properties of exponents that you learned in Algebra 1. So going through each of the properties, we have 4 properties: the product property, quotient property, power property, and the identity property. For the product property, we have log of m times n is equal to log of m plus log of n. So if we're multiplying, that's the same as expanding this into addition. Off to the side, we have an example. So if we have log of 2 times 4, this is the same as saying log of 2 plus log of 4. Then we have the quotient property. Quotient just means to divide. So this is log of m divided by n is equal to log m minus log n. So if we're dividing, when we expand this, this leads to subtraction. In our example, we have log of 4 divided by 7, which is equal to log of 4 minus log of 7. Then we have the power property, and with the power property, this states that if we have log of m to the n power, we can move that exponent in front of log. So I'm going to take this exponent here, and I'm going to move it in front of the log. So if I'm looking at my example, I have log of 4 squared is the same as saying 2 log of 4 because I take this 2 and I put it in front of the log. Then I have the identity property, which we talked a little bit about the other day. And the identity property states that if we have log base b of b, that is equal to 1. Remember, we talked about if we have 2 of the same bases, they cancel out. Well, when we cancel something out in math, it just doesn't disappear, it just turns to 1. So in these examples here, we have log base 2 of 2. Those cancel out. That turns to 1. Then we have log of 10. Well, remember, if we don't see a base here, we assume the base is 10. So that means log base 10 of 10 cancels out, and we're left with 1. And then we have natural log of e. Well, remember that natural log is the same as saying log base e. So that means here we have log base e of e, which means we have the same bases and they cancel out. All you need to remember is that natural log always cancels e, and e always cancels natural log. Okay, so let's look at some examples here. So in these first couple examples, we are going to expand our logarithms. Okay, so that means we're using the properties mentioned above. So looking at this part of the natural log, we have 5x to the 7th divided by y. Okay, well, since we have that division bar, I know that I'm going to use the quotient property that says that if I divide, I can expand this into subtraction. So I can rewrite this as natural log 5x to the 7th minus natural log of y. And then, since I have this exponent of 7, I know because of the power property that I could move this in front of the natural log. So I have 7 natural log of 5x minus natural log of y. That is my answer. Number 2. We have the log base 6 of 3x to the 4th. So since 3 is being multiplied by x to the 4th, I know I'm going to use the product property that states if I have something multiplying, I can expand it to addition. So this can be written as log base 6 of 3 plus log base 6 of x to the 4th. Notice in the first problem, I had natural log. That's why I wrote natural log twice. Here, I have log base 6, so I'm going to write log base 6 twice. Okay, whatever those bases are in the logs doesn't change. We're never going to change it. It's just going to be expanded using whatever properties we're going to be using. Okay, and then also you should see that we have an exponent of 4 here, and we're going to put that in front of the log. Okay, notice that this exponent is only attached to this log base 6 of x. So that means we do not put the 4 over here as well. Okay, it's only attached to this one. Okay, so because of the power rule, we can rewrite this as log base 6 of 3 plus 4 log base 6 of x, and that is our answer. Number 3, we have log of 10x. Okay. Remember, if we do not see a base for log, the base is 10. So I'm going to rewrite this as log base 10 of 10x. And since the 10 and the x are being multiplied, I know that I can use the product rule to expand it into addition. So I can rewrite this as log base 10 of 10 plus log base 10 of x. And then notice here, when I did that, I now have bases that are the same, which means from the identity property, I can cancel them out and it turns to 1. So now this is 1 plus log x, and that's my answer. Okay, number 4, I have the natural log of e squared divided by x plus 1. So since I'm dividing here, I'm going to be using the quotient property. And the quotient property states that if I'm dividing, that means I have to change that into subtraction. So this is the natural log of e squared minus the natural log of x plus 1. Okay. Since I have this exponent here, I know that I can move it to the front because of the power property. So I could rewrite this as 2 natural log e minus natural log x plus 1. And because I have natural log and e together, I know that I can cancel them out because of the identity property. So that means I am left with 2 minus natural log of x plus 1. That's my answer. Okay. Now we're going to look at doing the opposite. So notice that these are already expanded, so I'm going to have to do the opposite and condense them back up. When I condense them, if I have anything that can simplify further, I'm going to make sure to do that. So I'm going to pay attention to only the first 2 logs. Okay. So I have log of 9 plus 3 log 2. So before I start condensing these, I should notice that I have a number in front of one of my logs. Well, if we think back to the properties and we think back, okay, what made this number come to the front? We can recall that from the power property that this used to be an exponent. So I'm first going to use the power property and rewrite this with the correct exponent. So this is log of 9 plus log of 2 cubed. Now I can use the product property and combine them into multiplication. So log of 9 times 2 cubed. And then I just bring down the minus log 3. Well, now that I have a subtraction here, I'm going to use the quotient property and turn this into division. So this is log of 9 times 2 cubed divided by 3. And if I put this into the calculator, I get log of 24 because 9 times 2 cubed is 72. 72 divided by 3 is 24. And that's my answer. Okay. Number 6, before I begin, I'm going to cross out this log 4 and make it a natural log of 4 because that was a typo. And then I'm going to start with the first 2 natural logs. Okay. So notice that I have a 3 in front of one of my natural logs, which means this used to be an exponent because of the power property. So I'm going to rewrite this as natural log 4 plus natural log 3 cubed. And then since there is addition, I know because of the product property that I can turn this into multiplication. So this is natural log of 4 times 3 cubed. And then I'm going to bring down my minus natural log of 4. And since there's a subtraction sign there, I know I'm using the quotient property to turn this into division as natural log of 4 times 3 cubed divided by 4, which simplifies to the natural log of 27. That's my answer. Okay, number 7. This is where on the notes it says, okay, make sure you're using PEMDAS. Well, notice that my first two here are already in parentheses. That means I couldn't simplify these two first. I have to pay attention to the parentheses. So I have log base 2 of x minus log base 2 of y. So that minus tells me that I'm using the quotient property to turn it into division. So this is log base 2 of x divided by y. And then I'm going to bring down plus 3 log base 2, 4. And since I see a number in front of my log, I'm going to make it an exponent above the 4 because of the power rule. So this is log base 2 of x divided by y plus log base 2 of 4 cubed. And then because of that plus sign, I know I'm using the product rule and turning this into multiplication. So this is log base 2 of 4 cubed x over y, which can simplify to log base 2, 64x over y. That's my answer. Okay, last one, number 8. Notice in number 8 that we have this x minus 1 in parentheses. All this is telling us is that this entire term belongs to this log. So instead of saying, okay, there's a minus there, let me use the quotient property to turn it into division, you should see, well, wait, there's only 2 logs here. So that means this is one term and this is the other. So before we do anything, you should notice, oh, there's a 1/3 in front of this log. Well, let me move this back as an exponent above the x because of the power rule. So I would rewrite this as log of x minus 1 minus log of x to the 1/3. Now we're subtracting the 2, so because of the quotient rule, I know that I can turn this into division. So this is log of x minus 1 over x to the 1/3 power. Well, if you recall from last unit, we talked about radicals and how radicals can also be written as exponents, where that denominator is the root of our radical. So since we have x to the 1/3 power, that's the same as saying the cube root of x. So I'm going to rewrite this as log x minus 1 divided by the cube root of x. And that's my answer.